What is quantum mechanics?
Quantum mechanics is the paradigm of physics that came into being in the early part of the 20th century that replaced classical mechanics. And it replaced classical mechanics in a weird way that we're still coming to terms with. So in classical mechanics, you have an object, it has a location, it has a velocity, and if you know the location and velocity of everything in the world, you can say what everything's going to do. Quantum mechanics has an aspect of it that is kind of on the same lines. There's something called the quantum state or the wave function. And there's an equation governing what the quantum state does. So it's very much like classical mechanics. The wave function is different. It's sort of a wave. It's a vector in a huge dimensional vector space rather than a position and a velocity. But okay, that's a detail. And the equation is the Schrodinger equation, not Newton's laws, but okay, again, a detail. Where quantum mechanics really becomes weird and different is that there's a whole nother set of rules in our textbook formulation of quantum mechanics, in addition to saying that there's a quantum state and it evolves in time. And all these new rules have to do with what happens when you look at the system, when you observe it, when you measure it. In classical mechanics, there were no rules about observing. You just look at it and you see what's going on. That was it, right? In quantum mechanics, the way we teach it, there's something profoundly fundamental about the act of measurement or observation, and the system dramatically changes its state. Even though it has a wave function, like the electron in an atom is not orbiting in a circle, it's sort of spread out in a cloud. When you look at it, you don't see that cloud. When you look at it, it looks like a particle with a location. So it dramatically changes its state right away. And the effects of that change can be instantly seen in what the electron does next. So that's again, we need to be careful because we don't agree on what quantum mechanics says. So that's why I need to say, like, in the textbook view, et cetera, right? But in the textbook view, quantum mechanics, unlike any other theory of physics, gives a fundamental role to the act of measurement.